Nice. Okay. So the first concept builder. Balanced versus unbalanced forces. I said only to do the apprentice level things. What is going on here? This here says forces below are acting upon a leftward moving object. So this thing is moving to which direction? It says to the left. Okay. So what's going on here? You're going to say, all right, so first off, this is what first question is. Is there a net force? All right, we're assuming right now that the top and bottom are equal, so they balance out. So is there another force then? Yes, and it's going to which direction? This arrow right here that I'm looking at is going to the left. It does say it's moving to the left, but what direction is the net force? To the right. What force opposes motion? Friction. So would you think this thing is speeding up or slowing down then? I would think it would be slowing down. And if there's a change in motion, then the forces are unbalanced. Dead away. Okay, so what's going on here? Forces are acting upon a rightward moving object. All right, so top and bottom, are they balanced? Yup. What about left, right? They look like it to me, right? So how, if everything is balanced, what is true? You are not going to change your state of motion. So you can be moving at a constant speed in a straight line. You don't have to be speeding up or slowing down. So balance means either the object's going to be chilling at rest or at a constant speed in a straight line. It's not going to change its motion. Oh, snap, what's going on up here? These forces are acting upon an upward moving object. So right off the rip, is this balanced or unbalanced? Unbalanced. You should be able to tell just by the difference in magnitude. Okay. So if this thing is moving upward, what direction is the net force though? Guys, what direction is the net force here? Is it up or down? Which arrow is bigger? Down. Therefore, opposite directions, what do we do with them? To subtract. The net force is going to be bigger going downward. But this thing is saying it's moving upward. So if the down arrow is bigger, I know what you were trying to say. Yes, slowing down, not speeding down. Well, its speed is decreasing. How about that? What's going on here? Is this balanced? I can tell right off rip. What is it? Hell yeah. Then let's take a look at this. This thing is moving to the left. So if this thing is moving to the left, what direction is the net force? Top and bottom basically balance each other out. Left and right. Which arrow is bigger? The right one. So the net force is going to be going to the right. If the object's moving to the left, but the net force is to the right, what does that got to tell you? Slowing down. Masters. Look at shit. Okay. Then we had this thing here. Match this thing. We got a bundle of hay that is attached to a truck by a rope, and it is moved across dirt at a constant speed. So, is it going to have gravity? It's going to have weight, yes. If it's on the surface, then we're going to have normal force. It is not moving up or down, so those two are equal. Here, there is a tension force and friction force. Now, this could be a possibility. This could be a possibility. Let's see. Is this going to be it? No, because it's getting dragged to the right at a constant speed. We don't have our tension force here. Okay. This would tell us that it would be accelerating to the right because the net force is to the right here. But it's moving at a constant speed, so we need something to balance that out. Applied force will be like if you're pushing on it or pulling, but this is when they're saying something that has like a rope, string, spring, those are all tension forces. Aha, this is going to be the one. Here, because friction, these little lines here are indicating to us that they are equal.
Are they equal
moving at a constant speed? So if the net force is non-zero, there's going to be a change in speed. If the net force is zero, no change in motion. Whatever it's doing, it's going to keep doing. Straight line constant speed or at rest. Skydiver with an unopened chute is falling downward through the air at a constant speed. So constant speed means what? Net force has to be equal to zero. So does air resistance act downward and gravity act upward? Hell no. Does gravity act downward? Yup. Air resistance going upward. Okay. Is this going to be it? Nah, because again, they're saying constant speed. So the air resistance here needs to be equal. So that can't be it. We don't have a normal force because we're not on a surface. Bing, bang, boom. That should be our winner. A custodian pushes a crate to the right across the gym floor at a constant speed. So gravity, force of gravity is there going to be? Yes. Is there going to be a normal force? Yes. Is there going to be an applied force? Well, yeah, he's pushing it, so that's your applied force. Constant speed. Right now, this is telling me that friction is less than the applied force. So this would mean that it would have to be accelerating. It doesn't tell us that that's what's going on here. So no. This would be hella acceleration. There's no resistance to it whatsoever. It's going to the right. Friction acts opposite of motion, so that just is wrong. This would be the winner. Leftward moving car skids to a stop with locked wheels. Let's see. We have grav, we have normal force. Okay. It's moving to the left and it comes to a stop. So I'm thinking we're looking at friction. Friction has got to go to the right. So I'm thinking we got this guy here. Okay. A rope is pulled upward with a rope is used to pull a bucket of water upward at a constant speed. So you need the two forces here to be balanced, but it's not normal force because it's on a it's not on a surface. This is what I'm assuming tells us this is double. Yep. Tension and our weight downward. Okay. So that is essentially, guys, something that we needed to have to go through our little review thing there. And then again, for the homework from yesterday, I'm going to wind up posting this a little later. We're about to take our quiz. All right, if you saw something like this, it should tell us that we are speeding up going to the right. We are either moving to the right or not moving at all at a constant speed. So this thing is either staying at rest or it could be moving at a constant speed going to the right. Air resistance and gravity. This should tell us that it's still in the air, falling at a constant speed downward. Okay, so let's get ready to take our quiz.